So this review is your homework assignment from 2 days ago. I thought this would be a good opportunity to go through and talk about the problems. Not necessarily go through and give you the answers, but hopefully provide you enough information for each of the problems that you feel like either A, you've done it right and you can move on to the next problem, or to, as part of a growth mindset, go back, revisit the work you've done, and make some adjustments to your thinking if you have done the problem incorrectly, and then by correcting your mistake and then moving on. Problem number one is asking the question, find the missing angle measurements. If you don't take the time to look at the triangles or the shapes, you'll try to verify that they really are similar to each other. This one here, if you look at the angle measurements, they're telling you that the triangles are similar by angle because all three angles in both triangles are marked the same. So orientation is really important. So I was going to match things up in terms of the angles. The angle of the top K and R, we don't have either one of those, but we do have the angle at Q, which goes with J. We do have the angle at L, which goes with S, and then R and Y would be whatever is left over. You're not being asked here for any of the lengths, just angle measurements. In problem two, we're told we have a right triangle, and again, we've done right triangles before, and not all right triangles are similar, but in this case here, they are similar because they have marked all the angles with the same markings. And they're asking you to find the length of X. So again, we definitely have enough information. So hopefully, again, I'm going to use that idea of circling one of the triangles. So the 27 definitely goes with the 18, the 21 definitely goes with the X as those corresponding parts. So hopefully this problem here, you set up a proportion or at least establish a scale factor and solve for X. Always encourage you to think about circling one of the triangles if that is the best approach. Set your proportion up based on putting those numbers in the denominator. In problem 3 and 4, in problem 3 we have two Eiffel Towers, one being, let's say, the actual, the other one being a model. And a study day, so that we're both projecting similar shadows based on the ray of the sun. And they're asking to figure out how tall the tower is. So hopefully, again, like the previous problem, I'm about to set up a proportion where you're using the two numbers from the model as your denominators, and then set the corresponding sides. So the 0.9 and the 240 are the shadows, the 1.2 and the X are the heights of the two Eiffel Towers. And then from here, solve for X. In problem 4, you're trying to decide if the triangles are similar or not. And in this one here, unlike the previous problem, back on number 2, the issue here is that we don't have the three angles this time. And so do we really have similar triangles? And so we do have a pattern of side, but we're missing this side here as well as this side. We do have a pattern called angle. Again, we have one angle. And then we have a pattern called side, angle, side. And we have side, angle, side here, but we don't have side, angle, side here because we're missing DF. So in all three of the triangles, all two triangles here, we're missing a critical piece of information to be able to say the triangles are similar. So if you couldn't figure this one out, my suggestion would be to you, since we have right triangles, did you think about the Pythagorean theorem and using his theorem, Pythagoras' theorem, to come up with the missing side lengths? That's where I would suggest starting with this problem here. And if you didn't figure it out, and then once you get the third sides, hopefully you now have enough information to prove whether the triangles really are similar or not. Right. In this problem here, we're told we have three pairs of triangles that are similar. I always like to focus on angle measurements. And so, again, what I'm going to talk about here is about the pairings of the triangles, and then I'm going to leave the final step for you actually setting up the similarity statements, and also indicate which rule you are using, angle, side, or side, side, to justify the triangles that are similar. So the first one here, ABC, I notice I have two angles, 53 and a right angle. I always focus in on angles first, because especially when I have two of them, and do I have another triangle that has those two angles? And when I look through the picture, hopefully you see the same thing happens, the triangle below it. Nowhere else do I see that combination. It doesn't necessarily mean it doesn't show up somewhere else. I would go ahead and find the third angle here, which is 37 and 37. There is actually another triangle, G of H and I right here. It has 37, and the third angle is 53. So we definitely have, if you didn't think about the angles, we definitely have three triangles here that potentially are similar to each other, because we have the same three angle measurements. So that means we have multiple pairings of similar triangles based on angles. I make the same recommendation, again, focusing on angles. I got a right and 27, so I would find a third angle if you didn't, which would be what, 63 degrees. And if I look at the other two pictures, I don't see a 63 anywhere, or 27. I do see two 67s and a right, so I would definitely be focusing my attention on these two triangles, because again, by angle, they already have two pairs of angles matched up, which means the third angle, which is 23, will also have to match up. So in terms of the pairs, one triangle doesn't get used at all. And then we have three triangles that have the same three angles, and that will create multiple similar statements. And then we have the one pair that has just the 67, 23, and 90. This problem here goes along with the side splitter work that you did from 2 days ago. And so in doing this side splitter rule, we're looking at the lengths along the two sides that are being split. Because we had the length of AD as being 8, that means AE has to be 3, since 5 plus 3 is 8. And so I have 3 of the 4 numbers in that side splitter. So I recommended on one side putting the two pieces of the AD, and on the other side put the two pieces for AC. Make sure that you put them in the same orientation. In other words, the smaller triangle AE and AB, I made those the numerators, and then the bottom piece is part of the bigger triangle AD and AC, and make sure those are the denominators. And then from here, try to figure out the value of X. In the problem 7, we definitely have two triangles that are similar by angle again, because we have two pairs of angles that are the same. F, E are rights, and D and A are marked the same. So think about choosing the two sides from a triangle, and then figure out which sides correspond to 15 and 45, and then figure out the value of X. Starting with problem 8, we're trying to decide if the triangles are similar or not. And if not, why not? I think orientation, again, is extremely important. So problem number A, I would probably definitely redraw the picture. And I like to try to get things paired together, so that orientation, again, helps me decide if we have one of our 3 rules or not. So in this first problem here, we got 2 sides, but we don't have the third side. They're telling the angle D and angle B are the same. So it looks like the triangles are not similar, because we don't have side angle side. We have side angle in both of them. We don't have side, side, side because we're missing the side at the bottom. And we don't have angle, angle. So it appears in A you may have said no. But I would suggest to you, if you said no, did you consider the fact that both triangles were isosceles? And because when we have isosceles triangles, not only do we have two sides that are equal, but we also have two angles that are equal. And so that means in both these triangles, there should be another angle marked congruent to the B and the D. So if you didn't do that, think about the fact that triangles really are isosceles. There's a missing piece of information that might actually take our no answer and make it become a yes. In problem B, we have nested triangles. So they're sharing C for sure. We got parallel lines. So did you mark the corresponding angles as being the same? And if you did, then hopefully you recognize that the smaller triangle BDC and the bigger triangle AEC are both sharing the same three angles. So hopefully you came up with this one as being yes. And which pattern? Hopefully the pattern as well. In problem C, we have side lengths. And so keep in mind that the biggest issue we run into is side lengths, especially with side, 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 side angle side. Do we have the same scale factor? So even though it shows side, 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 it doesn't necessarily mean that the triangles really are similar to each other until we check that scale factor out. So we talked about previously the size of the pairings matters, so the longer sides go together. So 15 would go to 45. The 10 would go to the middle side, which would be the 30, and the 21 goes to the shortest side, which is the 7. And by pairing these up correctly, do we end up with the same scale factor? And if the answer is yes, great. We have similar triangles. And the answer is no, we have no angles, so that means the answer would be there's not enough information for this. In problem D, we have two angles, definitely one pair that's the same, but the other two are definitely different. So my comment to you would be is, did you take some time to look at the third angles to see if by finding the third angle, do we now have two pairs of angles that are the same? And if the answer is yes, then angle, angle works. We have no side lengths, which means side, 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 and side, angle, side can't work here. All right, problem 9 is we did probably similar to this over a week ago. So one thing is that we have right angles to begin with, and because we're looking at this mirror, the two angles being created at the mirror are going to be the same measurements. So these two triangles are similar by angle, angle. So again, I would recommend using the process of, again, circling that triangle, use those as denominators, and then pairing up the pieces that go together in terms of the shadows, the distance from the mirror and the height of the object, which would be the person and the tower itself. Problem number 10, we've been doing cross multiplication for all the portions, so hopefully you did cross multiplication here to figure out whether or not what the missing value would be for each of these. And the last problems, we're setting up a proportion, so try to figure out again a pair of sides that work. And again, I probably would redraw the picture, especially number 11, to make sure that I have all the sides paired up correctly. So try to find a completed pair, and then the other pair that's going to be about X, and then such a proportion based on that. Same thing with 12. Figure out what pair of sides go together to create a completed ratio, and then the other ratio will be where the X is at, and get the proportions up correctly, cross multiply. I'm going to stop here because of the time of the video, so if you would click on the next video, we'll finish up this activity.